everyone, and welcome to this presentation on validity and reliability in terms of evaluating measures. Another word for measures that I'll use is instrument or scale. So let's talk first about validity. When we're talking about validity in the case of instruments, this is not the same as external validity. So recall back to the sampling presentation and class discussions where we were talking about external validity having to do with the generalizability of a study's results back to the theoretical population based on the sampling method that was used. Okay, so that's external validity. Validity of an instrument has to do with its accuracy in terms of how well it is, targeted to the concept that it's trying to measure. This is my SAT attempt at target, but something relating to or looking like a target. But in any case, let's use the example that I use a lot, which is the Beck depression inventory. In this case, the question of validity for this instrument is how well is this instrument actually measuring the concept of depression? That's the question of validity when it comes to instruments. So there's different types, and we'll go over each one. The sort of most basic kind of validity that can be established is what's called face validity. And in this case, we're just looking at how the variables were operationalized on the face of it to see if they look like good measures of the concepts involved. And by on the face or on its face, it's just referring to like the face of the instrument, just taking a look at it. So let's look at one question from the Beck depression inventory that has to do with sadness. So I take a look at it and I say, okay, it goes from I do not feel sad to I feel sad all the way to I'm so sad and unhappy that I can't stand it. It looks to me like a good measure of sadness. But of course, then this is the weakest way to try to demonstrate validity, right? So one way to increase the validity would be to give this question to an expert or experts on depression and see if they think it is a good measure of sadness. Another type of validity is content or sampling validity. It just depends on something that I'll go over in a little bit, but it has to do with those quotations there. But in any case, trying to establish content validity would require showing that the instrument covers all the elements of the concept being measured. So for example, with depression, as we've talked about before, this is a big concept that includes things like sadness. Another element involves sleep disturbances, self-esteem, appetite issues. Another element is hopelessness. And in fact, there's multiple elements of this concept. So if we were looking at the Beck depression inventory, and this isn't even all of it, all of the questions, if we wanted to establish content validity, then we would take a look at these questions and say, okay, are all the elements of this concept being covered? So we start with maybe this first question, and that's with the one we went over. So it looks like it's covering sadness. The second one to me looks like it's covering hopelessness. I feel the future is hopeless, etc. The second one looks like it's about failure, which is involved in self-esteem. And we could go down the line and say, okay, it looks like all the elements are here. So let's get back to that sampling version. The only difference has to do with this word all in terms of sampling versus content. So in content validity, the instrument is trying to cover all the elements. With sampling, it's covering some of them. So the researcher might decide, okay, sadness, self-esteem, and hopelessness are the elements that the instrument is covering. So it has sampling validity. But again, this is still a weak way to try to demonstrate validity, and I just realized that weak is misspelled. So just ignore that. You know what I'm talking about. But in any case, it's still a weak way. And again, one way to increase it would be to give this to experts, to give the instrument to experts to judge whether content validity can be established. And when we do that, when we give the instrument to experts, this is called jury opinion. Criterion validity. This one is a little bit tricky, so just kind of bear with me. We'll go through it step by step, and hopefully it will make sense by the end. So with this validity, there is a criterion to which the instrument is compared. That's why it's called criterion validity. There's some outside criterion or criteria being used. So there's two types. The first is concurrent, and this is where we compare the instrument to a similar instrument that is already known to be a valid measure of the concept of interest. The second is predictive, where we compare the results of the instrument in question with future results. So let me give you an example of concurrent. Let's say I come up with the Dr. B depression scale, the DBDS. I give the DBDS to a sample of people. I also give them the Beck Depression Inventory, which has already been validated. So if the Beck Depression Inventory is a valid measure of depression, then, and I think mine is as well, and I want to establish concurrent validity, then there should be a correlation between the scores on my scale and the scores on the BDI. Predictive validity, by way in terms of an example, I have a sad one, which is the school to prison pipeline. So I think I mentioned in our history class how third grade reading scores can be used as a predictor of incarceration later in life. I mean, there's a little bit more to it, but because what are those reading scores representing? Poorly resourced schools, socioeconomic status, racism, etc. But in any case, these measures taken at one point are said to have predictive validity if later on, see how people are doing and compare the results. The next one is also a little bit tricky. It has a very long name, the multitrait-multimethod approach. This is the type of construct validity. And like I said, it's a little bit complicated, so let's just go through it step by step. So just follow along. So what does it mean by multitrait? Well, there's two or more measures. Your book says numerous. I'm just going to stick with two, but just know that it could be more. So two measures of concepts that theoretically should not correlate with each other, in fact, do not correlate in reality. So we have two instruments measuring two concepts. Those two concepts theoretically do not have a relationship. And so the instruments, the results of the scores of those instruments, of those measures, should also not correlate. This is referred to as discriminant or divergent validity. The multi-method part is that if you have two measures of concepts that theoretically do correlate with each other, then the results of those instruments should correlate with each other. And this is referred to as convergent validity because the two instruments are converging together. So let me give you an example of each, and hopefully that will cement the concepts. So if I have two instruments, one is for suicidality and the other is for aggressive behavior. And let's say I'm trying to validate suicidality. One part of this approach would involve comparing suicidality to some other concept that that there's no research to show that there's a relationship between. So in this case, aggressive behavior. Then the scores from my instrument on suicidality for a sample of people should not correlate with scores on the aggressive behavior instrument from that sample of people. So if I can establish that, then I've established discriminant validity of my suicidality instrument. Convergent reality is kind of like the opposite. So again, I have my suicidality instrument, but now I have this other valid measure of sense of hopelessness. These are two concepts that theoretically go together. There's a relationship between these two among people. So if I give these two measures to the same group of people, then the scores should also have a correlation. So I hope that sort of makes it a little bit clearer. If not, I can use different examples in class. Okay, so that's validity. Let's move on to reliability. Reliability has to do with consistency, and consistency, and consistency, more consistency, and you're asking consistency of what? Consistency across repeated administrations. So reliability of a measure is its ability to always yield the same or similar scores every time that it's used. So let's talk about test-retest reliability first, because it's sort of the more common one that I think people think of. So in this case, we have a group of people, and in my example, they are given the Beck depression inventory. Some time passes by, maybe an hour or two. That same group of people is again given the Beck depression inventory. Well, if I compare those two scores, the average scores, they should be pretty similar. There should be even a relationship between those two scores, because what's changed? Ideally, nothing has changed, so the scores should not be vastly different. Oh yeah, the multiple testing effect. So one problem with test-retest reliability is that there might be an effect on the second instrument's results based on people having seen it previously. And this can be for test questions because people remember the answers, but it could also be for instruments like the BDI. You know, people may not want to give the same answers, or they try really hard to give the same answers, or, you know, there's other effects that your book goes into. And it is something that researchers need to be aware of. In terms of the word correlation, I did want to just kind of briefly go over what I mean by correlation, or what your book means by correlation, which we both mean the same thing, just so it's kind of putting it into the context here, because we've talked about correlation in terms of relationships between variables, but here it has a very specific meaning. So what is that meaning? It's Pearson's R. So this is an actual statistical test that is run to see if the relationship being observed between the scores of those two instruments, or between the scores of multiple administrations of the same instrument, are related. Sorry, I'm just trying to see if that was a grammatical sentence. I'm not sure that it was, but I hope you know what I meant. So R ranges from 0 to 1, so it's a proportion. And depending on the number, we get a sense of how strong the relationship is between two variables, or in our case here, between scores on two instruments or scores on multiple administrations of instruments. And again, it's a statistical test, so we do get levels of significance in terms of whether the relationship is significant at 0.05, 0.01, 0.001, like I mentioned before, in terms of what those are. But here I want to kind of give you a sense of what the number, what R actually means in terms of its number. Well, the higher the number, the stronger the relationship. So going from 0 to 1, again, the higher the number, the stronger the correlation. So an R of 0 to 0.25 is really low, so there's no real relationship here, and it's unlikely that it would come back as statistically significant. Oh, and by the way, I'm giving you these ranges here, but they're a little bit arbitrary. Your book kind of gives you a sense of, oh, if it's over this particular number, then it means it's a very strong relationship. But I've seen people call R's of less than that strong relationships as well. So just keep that in mind. Okay, so an R of 0.25 to 0.50, that's what? What is my problem with this word weak? I do know how to spell it. Maybe I'm just anxious about the weeks going by in this semester because we're already week 9. Okay, anyways, it's a weak relationship. 0.50 to 0.80, moderate relationship. But again, like I said, I've seen I think 0.70 is fairly high and fairly strong. But according to your book, 0.80 and higher is what's considered a strong relationship. But again, I'm obviously I'm not going, 0.26 to 0.50 or 0.259999 because again, these are sort of arbitrary in terms of exactly where. It's just kind of general ranges. But okay, just that's a little side note. Oh wow, that's a little confusing. Sorry, I should have done this slide before the other one, but too late now. Okay, so we were talking about the multiple testing effect before my correlation slide kind of snuck in there. I think I was supposed to go over that earlier. Not sure what happened there, but okay. One way of addressing the potential multiple testing effect is to take that sample of people, that one group of people, and break them into two groups of people, separate people. One is called the experimental group, and they get tested twice. And then the other is called the control group, and that group gets tested once. And then the results are compared, and hopefully there's a correlation between the two and not a whole lot of change for the experimental group in terms of the first test versus the second test. And by test, we're just talking about giving them the measure. So in this case, I would be giving them the BDI, the first group the BDI, waiting a few hours, giving them the BDI again, and then the second group who gets the BDI during the second round. Okay, another type of reliability is called multiple or parallel forms. So for example, let's say I have one version of a midterm, then I would have a second version of the midterm, and hopefully when I give these two different versions to this same group of people at the same exact time, then there should be a correlation between these two scores, the average scores. And that's pretty much all I have to say about that. Let's move on to the last type of reliability, which is what's called internal consistency or the split half approach. So in this case, we have one instrument, for example, the BDI, and we want to know how consistently reliable are the items on this instrument. So just within the instrument itself. This is different than the other forms, which were about either different forms or, different instruments or being administered at different times. Here it's the same one, and except that it is broken into two parts. So, and not like down the middle here, but randomly ordered questions are split into two separate mini instruments, if you will. And then there should be a correlation between those two halves. The R should be strong. Okay, the last thing I want to talk about is when it comes to validity and reliability is what's called errors in measurement. And this idea is that there's no such thing as an exact, perfect measurement of a concept. So this leads us to what's called the true score theory. And this is the idea that any score that we observe for any individual person, but of course we're not really interested in the individuals in research. In terms of quantitative research, we're interested in the averages. So I'm going to just refer to these as average observed scores. So like the score on the BDI for the average score for a group of people. Well, that score, that average, is actually comprised of what the true score is in reality, in real life, that we can't actually get at, but that exists, plus some degree of error. Now, ideally, we want that error to be very small, and there's actually ways of measuring that error. For our purposes here, though, we just want to know that there are two types of error. There's what's called random error, and that's given the notation E subscript R, so error random, and systematic error, which is given the notation E subscript S, so error systematic. Random error we don't worry about. Oops. Random error we're not so concerned about because random error affects everybody. It's what's systematic error is what we're more concerned about. And I'll go into detail about these two in a minute. Right now, I want to just kind of revise that true score theory so that if we have the observed score, so that's the average that we get from our study, then we say that it's comprised of the true score, what if we could measure perfectly what that true average would be, plus random error, plus any systematic error. Okay, so now let me go over random and systematic. So random error, it has to do with any factors that due to just chance alone could affect measurement of any variable or variables across the sample. So things like people's moods, right? They vary. It's, not something that is predictable. It's random. Random error does add variability to the data, but it does not affect average scores. If I were to give an instrument to multiple groups of people, everyone's mood in those groups individually would vary, but overall the averages would not change. Versus systematic error, which are any factors that consistently affect measurement of a variable. So this could include things like data entry errors, certain groups not responding to certain questions. It could be the way that questions are being asked. But in any case, systematic error involves bias in the data, and it does affect average scores. So it's something that researchers have to try to minimize as much as possible. And your book goes over some of those ways to do that. So how to reduce measurement error in general. These are just ones that are other than what's in the book. We can pilot test the entire study, pre-test instruments. We've talked about what those are. We can double check the data. We can triangulate across several measures that might have different biases. And by triangulate, we just mean using multiple instruments to try to get at the core of what we're trying to understand. Okay, here are the sources of the images. Oh no, it didn't work. This is supposed to be a GIF, whatever it's called. But oh well. Thank you for watching and listening and paying attention, and I will see you next time.